The TI-36X Pro has a built-in normal distribution cumulative probability calculator. This will make it very easy to find area under the curve for a normal distribution. I'm going to show you first how to do this for a standard normal distribution where we're calculating probabilities based on z-scores. So with a standard normal distribution, the mean is 0, the standard deviation is 1. And if we're looking for the probability of a z-score being between negative 1.67 and 0.67, then we're looking for the area that's shaded under the curve in the diagram on the screen. So to access this built-in function, we're first going to enter in the distribution menu, select normal CDF, enter the mean and standard deviation. These boundaries are simulating negative infinity to positive infinity. Now these calculators don't have an infinity button, so we're using numbers like 10 to the 99th power to represent positive infinity and negative 10 to the 99th power to represent negative infinity. So I'm calculating total area under the curve right now, and we know that the total area under a normal curve is equal to 1. So let's try it again, but this time let's put in the boundaries that we would like to use for the z-score. I'll click Solve again, keeping my mean and standard deviation the same. This time I'm going to input the boundaries. The lower bound is how far left my area goes. The upper bound is how far right my area goes. So it's really useful to have a diagram here. Looking at the shaded area, I can see that the shaded area goes as far left as negative 1.67, so that's my lower bound, and the shaded area goes as far right as 0.67. That's my upper bound. So plugging those numbers in and then asking the calculator to calculate, we'll see that the area is 0.7011. And typically we only keep 4 digits after the decimal, but this calculator is providing more precision than what we would get if we used a table, for example. If I want to quit using the normal CDF function, all I need to do is go down to quit and then hit enter, or I can use the second function and quit to exit that menu. Let's take a look at another example of a normal distribution where we're asking about a probability, but this time we're not working with the standard normal. We're working with a normal that has a mean of 90 and a standard deviation of 3. And we're asking a question about what the probability is that a value from my data set is between 85 and 92. Again, I have a diagram to illustrate the area that we're trying to calculate. Let's go ahead and take a look at the calculator here. We'll enter into the distribution menu, select option 2, enter in 90 for the mean, 3 for the standard deviation. Our lower boundary is 85, our upper boundary is 92, and when we click calculate, we see the area under the curve is 0.6997. Now I will warn you that the calculator is being very precise here, behind the scenes, under the hood, so to speak. In the last example, I actually found the z-scores that correlated to the 85 from this normal distribution and the 92 from this normal distribution. However, I rounded those z-scores. I did that because when you calculate areas using a table, you typically only have 2 decimal place digits for your z-scores, so I wanted to simulate what it would look like if you were trying to mimic the probability from a table. In this case, though, the z-scores are not being rounded. The calculator is calculating them behind the scenes, and it's keeping more than 2 digits after the decimal. So we have a little bit of a discrepancy here. The probability is accurate to the first 2 decimal places because that's how far I rounded my z-scores. So if I were to round this probability, I would get 70%, and in the last example we got 70% as well. It's only the third and fourth decimals that are going to be off, and that's again due to the rounding of the z-scores from the previous example.